All right, so today we're going to take a look at lesson 4.8. So take a look at the problem of the day, pause the video and solve it. So 4.8, use the quadratic formula and the discriminant. First of all, let's take a look at what the quadratic formula is. You're going to want to write this in your notes. It's this big, long, complicated formula that says x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Now, you might be saying, well, why remember it? What's the point of us having to learn another formula? It can be used to solve any problem we did this chapter. So what does that mean? Any problem that you did. Do you know how we factored? We solved algebraically. We used complex numbers to solve algebraically. We completed the square. Anything that we have done this chapter, solving quadratic equations, it takes the place of that. All right, and that's what it's used for. Solving quadratic equations. So now you know chapter 4 is really long. So this formula, this x equals formula up here, can take the place of any single way we solve this chapter. Like I said, factoring, completing the square, and vice versa. So it's a long, complicated formula, but it's a one-stop deal. It works for every single one of them. Oh, 1 second here. So we're going to take a look at, well, how do we use this formula? How does it apply to everything? So if we take a look at the next slide here, it says using the quadratic formula to factor. I have a little note underneath it that says equation must be equal to 0. We have example 1 over here we're going to work with. So the first thing, before I could do these 4 steps, it must be equal to 0. If you look at my example, it's x squared plus 3x equals 2. We need to actually move the 2 to the other side. So let's see how this works here. All right. So I bring the 2 over as a negative 2. Equal to 0. Now number 1 says identify A, B, and C. Watch your signs. So if we just slide this down. My A is in front of the x squared, it's 1. My B is in front of the x, which is 3. My C, actually, is in front of, there's a number by itself. C should be negative 2. Sorry about that. I just realized I had an error here. It's okay throughout the rest of it. So the negative 2 is a number by itself, which is considered the C. So what we do is we plug it in. Step 2 says substitute into your formula. So we slide this down. Just take your time when you are plugging it in. It's negative b. So b is positive 3, so there's a negative in front of it, plus minus square root of 3 squared minus 4 times 1 times negative 2 over 2 times 1. Now be careful when you are solving this. I first, you'll see in the next line, I take care of the 3 squared, which is 9, and I multiply 4ac together. Then I multiply the 2 over 1, 2 times 1. I don't do too much at once because the common mistake I see is, because it's such a complicated formula, you tend to try to do too much at once, you mess up your answer, and there's no way, you have to go back to the beginning to figure out what you did. So I like to do a lot of time. You'll see with each of the problems, this is how I set them up. So 3 squared is 9, this becomes a positive 8, and 2 times 1 is 2. And then I'm going to simplify the square root again. 9 plus 8 is 17. Now you'll notice 17 I cannot split up further, right? 17 is a prime number. It's 17 times 1. And there's nothing else I could simplify. So this is us for following order of operations. We want us to write both answers. So do you see how we have that plus minus, just like before in the other lessons with them? Put 1 in the positive, 1 in the negative. That's my final answer. I can't simplify further. So now let's take a look at another example, and as we solve it, maybe you should pause the video and try it yourself. You're not going to see the steps anymore, but now you have them written down to follow along. Now there's a little note up top. I said, will there always be 2 real solutions? If we go back for a second here, these are 2 real solutions. Yeah, there's a big square root, and it's a complicated fraction, but they're both real solutions. I'm going to take a look at example 2. Now, I'm leaving out the work, and I'm going to go through each one of them. So you might want to solve it yourself first, and then check back with me. But let's go through letter A first. I have to move everything over to the left equal to 0. And then I have to combine like terms, so before I solve anything. I have 25x squared minus 30x plus 9 equals 0. Now, once you do that, label A, B, and C. Be careful, though. The one thing you want to be careful about is do not attach, like A is 25, not 25x squared. So do not include the variables. If you try and do that, you are not going to be able to solve it. It's going to be this big mess of a problem. So it's only the coefficients. Be careful when you plug in negative b. The b is already negative, but you see I have a negative out front. Minus negative becomes a positive 30, so be careful of that. I then simplify the inside. Negative 30 quantity squared. Don't forget your parentheses again. It's a positive 900. Negative 4 times 25 times 9 is a negative 900. What you see that's odd with this one is you see how it's 0? And square root of 0, this goes away. So my final answer is x equals 30 over 50, or x equals 3/5. How many solutions is this? This is one solution, right? So let me go back for a second. If you look here, we had two solutions, right? 1, 2. Here's a case where we have 1. So there's not always going to be two real solutions. We'll take a look at that in a minute. Let's take a look at B. B, bring the 5 over is negative 5. Here's my A, B, and C. And just check your work. Please be careful. I know it's a lot of work. I ask you to show all these steps because if you make one tiny little mistake, it's going to mess up everything. All right, these are not the kinds of problems that you want to be hasty with because it's going to really affect your answer. Just making this a little bit bigger. Take a look at this line. So you see us plugging them in. You see the simplification. Square root of negative 4. Do you see where we have imaginary numbers coming back into play? Square root of negative 4 is 2i. So I have negative 4 plus minus 2i over negative 2. Divide them both by, might be a little hard to see here, by negative 2. We get 2 plus minus I. Negative 2 has to be divided by both of them. So here's my answer, 2 plus I and 2 minus I. How many solutions do we have here? Well, we have 2, but aren't they 2 imaginary? Move that out of the way. This one's actually 2 imaginary. So there's actually 3 characteristics. So 2 real, 1 real, and actually it's one solution. I could add the word real to it if I wanted to. If I go back for a second, if you want to, we could say 2 real as well. Remember they're imaginary when it's an I. And then we have the third scenario where it's 2 imaginary because of the I. They're complex numbers. All right, so what do we do here? How to determine the number of solutions? We use it from the quadratic formula, but there's only a little part. And I'm going to go back in a minute. You might want to copy all this in your notes here. If I look back for a second, how did I know there's 2 real? Look under the square root. What's inside the square root? 17. All right. Let's look inside the square root here. What's inside the square root when I simplify? 0. Let's look at the square root here. Negative 4. So do you see how where it determines how many solutions is this little part here inside the square root? So it's actually a simplified version of this. It's the b squared minus 4ac, which is found inside the root. So to find out what the discriminant is, how many numbers of solutions, you simply need to do the part under the square root. Now, if under the square root, b squared minus 4ac is greater than 0, there's 2 real. It would look like something here because you have 2 x-intercepts that cut through the x-axis. If it's equal to 0, it's 1 real solution, which would be the vertex, 1 x-intercept. And if it's less than 0, there's 2 imaginary solutions, which means there's no x-intercept, which means it's somewhere out here. It doesn't cut through the x-axis. So what we're doing now is we're taking a look at the discriminant. So let's take a look at how we solve them. So we have x squared minus 8x plus 17 equals 0. We're going to determine the number of solutions to the equation. Once again, we are using that b squared minus 4ac. No square root, just what's under the square root. So once again, we have to label a, b, and c. A is 1, b is negative 8, c is 17. And we plug that into b squared minus 4ac and solve. We now get 64 minus 68. 64 minus 68 is negative 4. Now that's my discriminant. if I go back for a second, if we take a look, sorry, I have the little Spotlight app up. If you look back to your notes, if it's less than 0, I'll move this back down here. We know -4, which is my discriminant, is less than 0. So if it's less than 0, we have what? 2 imaginary solutions. So the first parts of these is actually solving what the discriminant is and seeing, is it less than, is it greater than, or is it equal to? Because it's less than 0, it's too imaginary. We're using that right from the chart. Let's look at another problem. X squared minus 8x plus 16 equals 0. Here's my a, b, and c. And I simply plug it into b squared minus 4ac. 64 minus 64 is 0, so my discriminant is 0. If I look back to my chart, 0 equals 0, so it's one real solution. And you see it before, when we did the quadratics, we actually figured that out as well, but we actually found the answers to the solutions. Here the discriminant is shorter because it's just telling you how many of each type. It's not giving you the actual answers. Let's look at one more. I'll move this all the way down here. You guys can take a look at it. A equals 1, b equals -8, c equals 15. Make sure they're all equal to 0. I know they are already equal to 0, so we're okay with that. As far as this move. We have 64 minus 60, which is 4. 4 we know. 4 is greater than 0. So we have 2 real solutions. Once again, based on our chart. And that's how you do the discriminant. Okay, well that's it for today's lesson. And I'm going to have to move this out of the way. Give me 1 second here. I'm going to work on problems at the end. Homework's problem of the day and 2 types of problems. Make sure you complete these for tomorrow.